Hi dears, today we can see CSIR NET Max from complex analysis. The first question, consider the power series summation 1 to infinity x power n divided by root n and summation 1 to infinity x power n divided by n. Then options, both converge on open minus 1 closed 1. Similarly, both converge on closed minus 1 comma open 1. Similarly, C and D. So for that, the given one is summation 1 to infinity x power n divided by root n. And the second one is summation 1 to infinity x power n divided by n. So this we have to check whether this is converged or not. At the particular point here it is given whether it is minus 1 or 1, because here you can see closed minus 1 is there for the B option. For the first option, closed 1 is there. So for that, first I am taking x is equal to 1. Okay, so that what it happened here, summation 1 to infinity 1 power n divided by root n. So this is summation 1 divided by n power 1 by 2. So we have the p test. We have p test which is summation 1 divided by n power p. This will be converged only when p is greater than 1. Right, and it is divergent if p less than or equal to 1. Here it is 1 by 2. The p value is what? Less than 1. So you can say that the series is divergent. Okay, and what about the second series, summation 1 to infinity, exists here 1, right? So 1 by n, and here also you can see the value of p is equal to what? 1. So which is also again divergent. So that you can say that the series is also divergent. So both also divergent for x equal to 1. So that you can see here x equal to 1. This is option A, that is divergent, but here the question it is given as convergent. So option A is wrong. Okay, for x equal to 1 we are getting convergent, but here it is we are getting divergent, and here we have convergent. So wrong. And what about C option, at x equal to 1 exactly 1 is convergent? No. For the 2 series also we are getting divergent. So option C is also false. Let's check for x equal to minus 1. So that I am substituting x equal to minus 1 for both the series. So here our series summation 1 to infinity minus 1 the whole power n divided by root n, and the second one summation 1 to infinity minus 1 the whole power n divided by n. So minus 1 the whole power n means itself this is alternating series, right? So alternating series means itself you have to use this Leibniz test. Okay, Leibniz test. So for alternative series, Leibniz test means the series, for example an, the sequence should be monotonically decreasing. Also limit n tends to infinity an is equal to 0. If these two conditions satisfied, then we can say that that particular series, okay, the particular series is convergent. This is Leibniz test. So first of all I am taking the sequence an. Okay, an is equal to what? 1 divided by root n. That is this. Okay, 1 divided by root n. Now limit n tends to infinity. An is equal to what? 1 divided by root n. As n tends to infinity, that will be tends to 0. If it's so, we can say that the corresponding series minus on the whole power n divided by root n is what? Convergent. Okay, this is the first one. Now I am taking the second series, that is an is equal to 1 second. Yes, it is convergent, and an is equal to 1 divided by n. Again we are look after the summation n to infinity 1 divided by n, right? So that is also converges to 0. So we can say that that's also convergent, right? This is also convergent. So now we can see that at x equal to minus 1. Okay, so at x equal to minus 1 both are convergent. That is correct, because just now we seen that both are convergent, but here D option none of them convergent. That is the wrong option. So according to this question, the correct option is B option. Let's see the next question. Second question. For n greater than or equal to 1, consider the sequence of function fn of x is equal to 1 divided by 2nx plus 1, gn of x equal to x divided by 2nx plus 1 on the interval x 0 comma 1. Okay, on the interval, that means x belongs to 0 comma 1. So two statements are given. The sequence fn converge uniformly on 0 comma 1. Second, the sequence fn converges uniformly, sorry, it is gn. Okay, gn. Okay, gn converge uniformly on 0 comma 1. So the options here it is given. First is true, then first is false. Then what about the C and D? Let's check this. Okay, whether it is converged uniformly or not. So for that, you have to take the first series, that is fn of x is equal to 1 divided by 2nx plus 1. Okay, 2nx plus 1. So for finding converge uniformly, the test is there, Weierstrass M test. Okay, that is the test. So for that Weierstrass M test, we have the condition that mn is equal to, that is limit n tends to infinity, fn x is equal to f of x, and mn that is equal to supremum of mod fn minus f. Okay, if that is convergent, if the limit is convergent, then we can say that is uniformly convergent. If this is convergent, then we can say that the corresponding one is what? Uniformly convergent. Let's take that. So first point is what? Limit n tends to infinity, fn x is equal to. So limit n tends to infinity, fn x, which is equal to what? Limit n tends to infinity, 1 divided by 2nx plus 1. Here denominator n is there, as n tends to infinity, 1 by n tends to 0, right? So this is f of x. That is our first step. Okay. Now, what about the second step? mn equal to supremum of modulus fn x minus fx. Okay. So for finding converge uniformly means you have to use the m test. So this is the condition. So this is the second condition. Supremum of modulus fn x is given in the question, 2nx plus 1 minus fx is here. What is the value? Is equal to 0. So that this is equal to supremum, and also in the question it is given on the interval 0 comma 1, right? So that here you have to mention it, x belongs to 0 comma 1. Okay, so here modulus 1 divided by 2nx plus 1 as x belongs to 0 comma 1. Now we know that x belongs to 0 comma 1. Okay, it converges, so that we have to take particular value of x. That is, I am taking here 1 divided by n. So if I am substituting n tends to 0, that means it will be converges to 0, infinity. Okay, sorry, infinity. This 1 by n tends to what? 0. Here it is saying that x belongs to 0 comma 1. So here 0 and 1. So it is excluded, but it is approaches to 0, right? So that suitable x value you have to choose. That suitable x is what? 1 by n, because 1 by n converges to what? 0. So that I am mentioning here supremum 1 divided by 2n. The suitable x is 1 by n plus 1. So by cancelling supremum of n and n get cancelled, 2 plus 1, which is 3. Okay. So that if I am taking the limit value, a limit n tends to infinity of m, that is limit n tends to infinity supremum of 1 by 3, that is not convergent. Okay, it is not convergent. It won't tends to 0. Okay. If it is not convergent means we can say that the corresponding series, that is fn of x, is not uniformly convergent. Okay, not uniformly convergent. So you can see that first one, fn converge uniformly is wrong. Okay, so that first option may not be correct. Let's see the second one. So first is wrong. This is wrong. Okay, it is not converge. It is not converge. Let's check the second one, gn of x, and see, option 1 is false. Yes, option 1 is false. Let's check the second also. Okay. What about B part? B is correct, because 1 is false. 1 is fn is not converge. So B is right. Let's check the gn option also. Gn is given on the question, x divided by 2nx plus 1. X divided by 2nx plus 1. So gnx is equal to x divided by 2nx plus 1. Same, we have to use MN test because for finding uniform conversion. So limit Gn of x is equal to limit n tends to infinity x divided by 2n x plus 1. Okay, so here also denominator n is there, so this will be converges to 0, so that is equal to g of x. The second step is mn is equal to supremum of what gnx minus gx, so which is equal to suprema x belongs to 0 1, gnx is x divided by 2n x plus 1 minus g of x is the value is here 0. Okay, the suitable x you have to take at what point, or we can say that at what suitable x that will be converges to 0. At I am taking x is equal to 1 by n. Limit 1 by n is what? Tends to 0. Right? So the suitable x is what? 1 by n. Because here we have 0 to 1. So supremum of 1 divided by n divided by 2n into 1 by n plus 1. Okay. So that here you can see that supremum 1 divided by n divided by 2 n and n get cancelled 3. So this you can write as supremum of 1 divided by 3n. Now we have to check the limit, so that limit n tends to infinity mn is equal to limit n tends to infinity 1 by 3n. As n tends to infinity 1 by n tends to 0. Okay, it is convergent. If this is convergent means the corresponding series is also is uniformly convergent. That is 2 is true. Okay, so 2 is true. Where it is? Yeah, it is here. 2 is true and 1 is false. Okay, so option C is right. Both are true is false. Okay, let's see the next question. Question 3. Let A be a positive real number. Which of the following following integrals are convergent? It's an easy one. Integral 0 to a 1 divided by x power 4 into dx. That is, if you are getting the answer is finite, then it is convergent. Okay, so here it is. That normally we will do x power minus 4, right? So x power minus 4 plus 1, which is minus 3 divided by minus 3 from the limit 0 to a, that is 1 divided by minus 3. Which is 1 divided by x cube from the limit 0 to a, which is equal to minus 1 by 3 into 1 divided by a cube minus 1 by 0. Okay, so which is equal to minus 1 by 3 into 1 by a cube minus infinity. So this means minus infinity some value. That is what? It is not convergent. Okay, it is not exist. Not exist means it is not convergent. Okay, not exist, so that we can say it is not convergent. So the first option is the it's not convergent. Okay, false one. Let's see the second one. Integral 0 to a 1 divided by root x dx. So second one, 1 divided by root x into dx. Okay, which is equal to the normal method x power minus 1 by 2. So when it is bring to the numerator, you will get or 1 divided by root x integral, we know that 2 root x. So from the limit 0 to a, that is 2 root a minus 0. Yes, it is finite. Okay, 2 root a. It is exist, finite, hence we can say it is convergent. So option B right. Option B right option. Let's check the third one. The third one here is integral. Yes, integral 4 to infinity 1 divided by x log x base e into dx. So for this type, we have to use the substitution method. I am taking log x is equal to p. Differentiate log x is 1 by x into dx is equal to dp. Okay, so that integral substitution limits also get changed, so that integral 4 to infinity dx divided by x means you can write dp then p. So which is equal to log p, right? P is what? Log x from the limit 4 to infinity, so that I doesn't change the limit because I am put here as p as log x, so that the limit is also 4 to infinity, x limit. Now log of log infinity minus log of log 4. Whatever here, this is infinity, It is not exist. Not exist means it is not convergent. So option C false. Okay. Let's check the fourth option. Fourth option, phi to infinity integral phi to infinity 1 divided by x into log x the whole square into dx. Okay. So here also I am taking the substitution p is equal to log x, dp is equal to 1 by x into dx. So that the limit here integral phi to infinity dx by x is dp. So this is p square, right? So p square 1 divided by p square. So p power minus 2. Take the integral, you will get minus 1 by p. Okay, check it. So from the limit phi to infinity, which is equal to minus 1 by infinity plus 1 by 5, which is equal to 0. Okay, which is equal to 0 plus 1 by 5, which is finite case, that is exist, which is convergent. Okay, so option D is the true one. Option D true. So according to this question, B and D are the right options. Next question. Question number 4. Let n be a fixed natural number, then the series summation m greater than or equal to n minus 1 the whole power m divided by m is dash. So this is an alternating series. So for alternating series means we have to use the Leibniz test. Leibniz test. So we know that for the Leibniz test sequence an is monotonically decreasing and also limit n tends to infinity an equal to 0 means you can say that the corresponding series is convergent. Okay. So here it is given. I am taking am equal to 1 by m. Okay, then check this one. This is monotonically decreasing sequence. You can put m equal to 1, 2, 3, etc. and check whether it is decreasing. Certainly it is decreasing sequence. Then I am writing limit m tends to infinity am, which is equal to limit m tends to infinity 1 by m. As m tends to infinity, 1 by m tends to 0. Okay. So we can say that the corresponding series summation minus 1 the whole power m divided by m is what? Convergent. Let's check. So divergent is not possible. Okay. Because we are getting it is convergent. So it is not. Let's see the absolute convergence. So for the absolute convergence, we have that summation modulus of an. That should be what absolutely convergent. Okay. If it is convergent, then we can say that summation an is absolutely convergent. Right? This is the condition. So let's check that summation modulus an. Modulus an means minus 1 the whole power m divided by m. That is equal to summation modulus of negative values. That's all will be positive. Then 1 divided by m. According to the p test, here it is 1. Right? So p test means p greater than 1 means convergent, that is this form. P less than or equal to 1 means divergent. Here you can see that it is 1, which is what? Divergent. Divergent means it is not absolutely convergent. If it is convergent, then you can say it is absolutely convergent. So it is not possible. Hence we can say that what? Hence we can say that it is not absolutely convergent. It is only convergent. Okay. So according to this question, this is false, this is false, and this is also false, because for all value it is already convergent, it is divergent. So for whatever n value take means also it is false. So the only option is convergent. Okay, thank you.